This is lesson 33-1 on prisms and pyramids. We scroll down here and it says that a dude is going into business for himself. He's going to design and build tents. And it says he usually builds a model of each tent before he creates the actual tent. As he builds the models, he thinks about two things, the frame and then the fabric. So here they show us, and here's the vocabulary word, these things down here are nets. And a net, it says over here, is a two-dimensional representation for a three-dimensional figure. So basically they tried to draw on a piece of paper what the image will be if it's laid out flat. So a couple of things. Some of you will have the ability to look at and say, oh, I know what this is going to look like when it gets put together. And some of you may not have that ability. I can do that with a little practice. So I'm just going to show you right here all I've done. This is what I mean with a little practice. I may not always be able to look at it the very first time I see it and get a picture of it, but if I take it and actually cut it and fold it just a couple of shapes, then my brain kind of remembers what happened when I folded the other problem, and I'm able to visualize what's happening. So here you can see I'm putting this together. It doesn't go together perfectly, but you can see that these three rectangles right here, this rectangle, this rectangle, this rectangle, end up being the sides of this polygon, okay? And then the two triangles that are at the end, these two triangles, that's what we would consider the base of this polygon to be, okay? So if you're one of those that struggle with seeing this put together in your mind's eye, then go ahead and take some time. You can draw it on a piece of graph paper. You don't have to print it out. You can draw it on a piece of graph paper and then play with it a little bit, because one of the things that you're going to be asked to do is look at a net. It's like a multiple choice question, and they have several nets drawn, and they're going to say which one will make a cube or which one will make a pyramid. And so this one, you have the ability to visualize the folding of that, then it's helpful, okay? Now, like I said, not everybody will need to do this, but some of you will need to, and I am one of those. Once I do it a few times, I get, oh, okay, I can do it in my head now, but I really had to touch it at least 2 or 3 times before I was able to do it. Alright, so let's look at some of these other terms. Faces are the polygons that make up the three-dimensional figure. So every single one of the shapes right here, these are all faces, okay? An edge is the intersection of two faces. So when I fold this piece right here, when I fold this piece up, when I bring it up, this piece right here and this piece right here are going to stick together to make an edge. So those two things right there will be where the two faces connect. And then, let's see, if I go over here, I can change color. Because this is another thing that they're going to ask you. It'll ask you, if they'll put ABCDs on here, and they'll say, as soon as this thing gets started, I'll show you what it'll say. Sorry, it's taken. Should have already had it open. Already 4 minutes into the video. I hate to throw the rest of it away just because I had made you wait a few seconds. So, okay, so I wanted to change this. So now this piece right here will fold over and meet that piece right there. Okay, so this piece and this piece right there will connect. So those are edges. Now a vertex is it's going to be a point where three things meet. Okay, so the three things, so I claim that this right here will be a vertex. What are the three things that are meeting? Well, this rectangle right here will meet with that triangle right there, will meet with this rectangle right here, because this is going to fold over and I'm going to connect them right there. So where you have three things meet, that's where you get a vertex. All right, and then this one right here, we would get a vertex right here in the middle at the top where they meet, because this piece would meet with this piece, would meet with this piece, would meet with this piece. Because notice it says three or more faces. So that would be a vertex. And this right here is a vertex. How is that one a vertex? Well, this triangle and this triangle and this square right there all connect right there at that vertex. Okay, there's the difference between an oblique prism, and we're using the word prism right here. Remember, a prism is one that has two congruent and parallel faces. This is a pyramid. I don't know how to spell pyramid. P-Y-R-A and pyramid. Okay, so it doesn't have that other. There's only one square. It would need another square up at the top to be a pyramid. To be a prism. So we need to know the difference between a right prism and an oblique prism, and the sides right here is what you do. It says the faces or the edges is what you need to pay attention to. So I'm going to click over here. I've found a page that shows a good representation. So here we see that at the edges right here of the vertical face is perpendicular to that horizontal base. So we've got a right angle right there. We've got a right angle right here. Over here, these are not rectangles because they're not right angles. These are kind of leaning sideways, so they are parallelograms. So oblique is when the prism's kind of leaning, is what it amounts to. If it's leaning or if it's not setting perpendicular to the sides and the bases are not perpendicular. These are all right. Prisms down here, the pinks are the ones that are oblique. All right, so let's see. What is the shape of the two? Oh, I was also going to see if you could try to draw it. So it's important that if you can visualize it being put together, then you can draw it. So we've got these two triangles. We know these two triangles, and then we've got that rectangle that's on the bottom. And then we've got this piece right here. So we've got a rectangle on the side, on the right side. We've got a rectangle over here on this left side, and we've got a rectangle on the bottom. So that's kind of a rough drawing of what that would look like. And this one, to draw pyramids, be sure that your bases, even though this is a square, draw it slanted, draw it more like a parallelogram, and then right in the middle above here, come up and put a point, and then you'll be able to connect those. Pretty easy. They're not perfect, but it's okay. All right, so the prism has three-dimensional solid with two congruent, that's what makes it a prism, two congruent polynomial parallel bases. And the two bases right here are always going to be the same shape. Sometimes they're rectangles, sometimes they're not. So the prism is named based on this. So this is what we call a triangular prism. Triangular prism. So these two things right here, the ones that are parallel, those are always called the bases. Even if it's not what they're sitting on. See this, the triangle is like towards the front of the figure. The other triangle is toward the back. They don't have to be sitting on it, but these are called bases. And the rectangles are the lateral faces. Okay, so if you see rectangles, it's a lateral face almost always. You can have a rectangle for a base, and then everything is a rectangle, but you don't have to have, the bases don't have to be rectangles. So what is the shape of the two congruent and parallel bases? These are triangles. What is the shape of the three lateral faces? Those are rectangles. Only because it was a right prism. What is the best name for the solid formed in net 1? So we would say this is a triangular prism. Use geometric terms to compare and contrast right prisms and oblique prisms. So right prisms have the lateral faces are rectangles, and oblique prisms, the lateral faces, are parallelograms. Okay, let's see, on lateral faces, the edges are perpendicular or parallel. So this edge right here is perpendicular to that edge right there. But this edge and this edge right here, those are parallel. Okay, and that's the only two relationships. They're either perpendicular or they're parallel. Actually, they could be skew, because they're not in the same plane and they don't intersect. But and over here, edges are not perpendicular. I think that pretty much completes the compare and the contrast. Yeah, for a pyramid, the big difference between, well, that's not true. For a pyramid and a prism both, the difference is the height. When you go back to these right here, the height of the right prism, I'll be able to write on this. The height of the right prism is going to be one of the lengths of its edges. Come on. So this one right here, this is the definition, the height of a prism is defined to be the perpendicular distance between the bases. So if you define this bottom right here to be the base and this top to be the base, then the distance between those bases, the perpendicular distance, will be that edge right there, because that is a perpendicular distance. Over here, in order to find out the height between this base and this base right here, we're going to have to drop a perpendicular and find out what that is, because it's not going to be the edge of that prism. We have to measure how far it is, because it's leaning over, so we're going to have to measure. So same thing with all of these down here. So this one right here, to find out how far this triangle is away from that triangle that's down there, we're going to have to drop a perpendicular and find this distance, okay? Because that's the distance between two shapes. You always measure distance perpendicularly, not slanted. So that's the difference when it comes to heights. Now for pyramids, if it's a right pyramid, then this point of this vertex up here is going to be perpendicularly placed immediately above the middle of that base. This one over here, you can see it's leaning, okay? So this base is, right here, and this had to come down to the same level as that base. But since the tip is not in the middle of the base, then we have to find out how far it is to the floor. So again, that's just like a pyramid that's leaning over. You've got these sides over here that are a lot longer than these sides over here because it's leaning. So on both of these, what is the shape of the base? They're both a square. This one may not look like it's a square, so you may have to be told, but usually, almost always, especially in the geometry, the base usually is a square. It says an oblique pyramid, the intersection of the lateral faces, the top point is not directly above the center. That's what I just said. What's the best name for the solid formed in figure 2? And figure 2 was on the previous page. So that was this one right here. So that was a square pyramid. It was a square pyramid. Okay, and it says use geometric terms to compare and contrast right pyramids and oblique pyramids. So it would be exactly what they said right here. The right pyramids, the vertex is above the center of the base, and on the oblique pyramids, it is not above the center of the base. The distance on the right pyramids, the distance from the vertex to the center is the height. On the oblique pyramid, it is how far it's the perpendicular distance from the vertex to the plane the plane containing the base. It may not actually be over it. It may be the plane that the base is on. So that would be my compare and contrast. In this figure shown is a hexagonal pyramid. Locate the net for this pyramid on the worksheet. So I didn't give you a worksheet. So here I will just attempt to draw it. So let's get the hexagon going. This is my rule for drawing a net. My rule for drawing a net is draw the base first, okay? And then you have the faces to draw. So attached to each one of these is a triangle. And the triangles should be the same size, and they should be isosceles, because I believe this is and then that should get you your net. You can dot those lines right there if you want to, but you've got the base, and then you've got the 6 triangles, 1, 2, 3, 4, 5, 6, and that would be the net. So the vertices are going to be A, B, C, D, E, F, T, A, B, C, D, E, F, T. List the base edges. So it would be AB, BC, CD, DE, EF, and FA. There should be 6. 1, 2, 3, 4, 5, 6. list the lateral edges. So the lateral edges were going to be the ones that go up to the vertex. So we have AT, BT, CT, DT, ET, and FT. And list the lateral faces. So that would be triangle, ABT, triangle, BCT, triangle. That looks like A, but it's not. It's triangle, CDT, triangle, DET, triangle, EFT, and triangle, FAT. I think I'm going to stop the video right here because it's just been going on a while, and that looks like a lot to fill in. So catch you on the next video.